So this is our third and final video on chemistry mole calculation questions. In this lesson, we're going to tie in all the knowledge we've gained from parts 1 and 2 regarding mole to mass calculation questions and excess/limiting reagent approach style. If you haven't seen part 1 or 2, please do so. I'm going to attach the video links in the description box. Now, before I approach this question and show you my plan of attack, I want you to pause the video now and take 5 minutes to solve this question yourself. So pause the video now. Now, we're going to go through the solutions. My approach is, whenever I see any calculation question, I always like to write my chemical equation with its associated data. Before I even do that, I want to approach a very key point in this question, which is that we've been given data about 2 reactants and asked to find a product. That should straight away recall to you that this is an excess limiting reagent question. So let's approach it. So we see these reactants are sodium carbonate and hydrochloric acid. Now, with any acid-carbonate reaction, we always form a salt. So in this case, the salt is going to be sodium chloride. Remember, if you're ever stuck, the negative ion of the acid and the positive ion of the base always combine to form the salt. So if salt is sodium chloride, we also get water. And since this is a carbonate neutralization reaction, we also get carbon dioxide produced. So adding in all our states here, the sodium carbonate is originally a solid. It's added into an aqueous solution of hydrochloric acid. The salt produced is dissolved in the acid and it's water, hence it's aqueous, and your water is in liquid state. So now let's look at balancing our equation. I see 2 sodium on the left-hand side. I'm straight away going to balance it by adding 2 sodium on the right-hand side. Now that adds 2 chloride on the right-hand side, so I'm going to add 2 chloride on the left-hand side. And this should be our balanced equation. Now let's write down our data, which is that the concentration of sodium carbonate is 0.0479 moles per liter. The volume is 27.9 ml. And for hydrochloric acid, the concentration is 3 moles per liter, and the volume is 37.64 times 10 to the power negative 3 liters. Now, remember, step 1 is always find the number of moles of both reagents. So the number of moles of sodium carbonate can be found by using the concentration formula here, where concentration equals number of moles over volume. So N must then equal to CV, and in putting the values for sodium carbonate, we should get a final value of approximately 0.0013 mole, which I'm going to store as A. Now comparing that to hydrochloric acid, we're going to do the same approach. Now recall, this is not our final step. What we must now do is divide each reagent by its respective stoichiometric ratio. So we see a 2 in front of hydrochloric acid. I'm going to divide this by 2. I see a 1 in front of sodium carbonate. I'm only going to divide it by 1. And hence now I'm comparing 0.0013 with 0.056546. Either way, HCl is the excess reagent, as 0.05 is greater than 0.0013. And that leaves us with sodium carbonate being the limiting reagent. Now you should have got up to this stage. This question is here to teach us a very important point about excess limiting reagent questions. Let's go back to our thought diagram. The reaction in an excess limiting reagent question occurs over the overlap of the excess and limiting reagent here. Now, if this section here is all excess reagent, and the section in blue, or the section I'm going to circle now, is the reacted portion of that excess reagent, we'll label that reacted. And the entire puddle of the excess reagent is the total number of moles of the excess reagent. So we have the reacted number of moles of the excess reagent as the space occupied by the yellow puddle. We have the total number of moles of the excess reagent as this entire space here. And hence, logically, the excess number of moles must be equal to the total number of moles minus the reacted number of moles. So, in simpler terms, this larger puddle in blue minus the tiny reacted puddle subtracted will give you all of this excess space here. Now in this question, they've asked you to find the concentration of excess reagent remaining. And for that, we need a two-prong attack. We need to find the number of moles of the excess reagent, and then we can divide that by volume of the entire solution to get concentration. Now this equation here, I'm just going to label it, this equation right here, is the most important equation for this question. If you cannot derive this logically, you will not get the answer. So let's think about this. If we want to find the number of moles that reacted, we have to apply the stoichiometric ratio. And we have to use the limiting reagent in this stoichiometric ratio so we can get the number of moles of HCl here that actually reacted. Now to find the total number of moles, that is simply this value over here, the 0.11292. Remember, we do not use this 2 value here. This is simply to determine the excess versus limiting reagent. So we know the total number of moles. We simply need to find the number of moles that reacted. So I'm going to apply the stoichiometric ratio where I put what I want, which is the number of moles of the excess reagent HCl over what I have, which is the number of moles of my limiting reagent sodium carbonate. And when I equate that, in front of HCl, I see a 2. In front of sodium carbonate, I see a 1. So that tells me that the number of moles of HCl is equal to 2 times the number of moles of sodium carbonate, which is equal to 2A, given that A is the number of moles of sodium carbonate. So now I've got the number of moles of HCl that has reacted. So let's put it back in the formula where the number of moles of excess HCl is equal to this total value here, this large total puddle, which is 0.11292, minus the number of moles of HCl that reacted. And that is simply 2A. And that should leave me with a final answer of approximately 0.11 moles. I've got the number of moles, but the question is asking me for the concentration of HCl that's in excess. And for that, I simply have to use C equals to N over V. I've got my number of moles here. And let's say I stored this to the correct total value as C in the calculator. Now, in terms of volume, which volume should we use in this question? Do we use the 27.9 ml or the 37.64 ml? The key to this question is that we use the sum of both volumes, because this entire reaction is happening in a beaker which has had this volume of solution added to this volume of solution. So the total volume is 27.9 ml plus 37.64. This is a big silly mistake students make. So let's ensure we do not make that. So factoring that in, our final concentration should yield us 1.682 moles per liter. And recall, our final answer must be to the lowest number of sig figs as provided in the question. And as you can see, 3 is the lowest number of sig figs in the question. So our final answer will round off to 1 sig fig. So we have a total of 2 moles per liter. And that is to 1 significant figure. And that concludes our lesson.